The multiverse theory: are we just one of many universes? The multiverse theory: are we just one of many universes? Have you ever wondered if our universe is the only one that exists? The concept of multiple universes, known as the multiverse theory, has intrigued scientists and philosophers for centuries. According to this theory, our universe is just one of an infinite number of universes. Each of these universes can have its own laws of physics, properties, and even different versions of ourselves. While his idea might sound far-fetched, it is a legitimate scientific hypothesis that has gained traction in recent decades. In this article, we will explore the multiverse theory and the evidence supporting its validity. The origins of the multiverse theory can be traced back to ancient Hindu mythology, where the concept of a multiverse, or lokos, was described in texts like the Puranas. However, it was not until the late 20th century that modern scientific theories began to suggest the existence of multiple universes. One of the earliest proponents of the multiverse theory was Hugh Everett, an American physicist who developed the concept of the many worlds interpretation of quantum mechanics in the 1950s. According to Everett, every time a quantum event occurs, the universe splits into multiple branches, creating a multitude of parallel universes. This interpretation allows for the existence of alternate realities, where every possible outcome of a quantum event is realized. While Everett's ideas were initially met with skepticism, they laid the foundation for further research into the multiverse theory. In the 1980s, physicist Andre Linde proposed the concept of eternal inflation, which suggests that our universe is just one bubble in a vast cosmic ocean of expanding universes. Support for the multiverse theory also comes from the field of string theory, a branch of physics that attempts to unify the fundamental forces of nature. According to string theory, our four-dimensional universe may be just one of many possible configurations of the fundamental strings that make up reality. Each configuration corresponds to a different universe, some of which may have different dimensions or physical laws. While the multiverse theory is an exciting concept, it is important to note that direct evidence for multiple universes is currently lacking. Since universes outside of our own are inaccessible, this rely on theoretical models and indirect observations to support the idea. One such observation comes from the study of cosmic microwave background radiation, CMB. The CMB is the residual heat left over from the Big Bang and is considered one of the strongest pieces of evidence for the standard model of cosmology. However, the CMB also reveals anomalies, such as temperature fluctuations that cannot be explained by our current understanding of the universe. Some scientists argue that these anomalies could be evidence of collisions or interactions between our universe and other parallel universes. Another line of evidence comes from the study of the fine-tuning of our universe's physical constants. This fine-tuning has led some to propose the existence of a multiverse landscape where every possible combination of physical constants is realized in different universes. In this scenario, our universe's parameters would appear fine-tuned simply because we exist in a universe that is compatible with life. Critics of the multiverse theory argue that it is highly speculative and lacks empirical support. Despite these criticisms, the multiverse theory continues to captivate the minds of scientists and philosophers alike. It offers a tantalizing possibility that we are not alone, that there are other versions of ourselves living in different universes, experiencing different realities. While the concept may seem like science fiction, it is grounded in rigorous mathematical models and the search for empirical evidence. As we delve deeper into the multiverse theory, questions arise regarding the implications of multiple universes. One intriguing aspect is the idea that there could be alternate versions of ourselves living in these parallel universes. These alternate versions, often referred to as multiverse doppelgangers, could have made different choices or experienced different outcomes in their lives. The concept of multiverse doppelgangers raises philosophical questions about free will and determinism, as well as the nature of identity. If every possible outcome of a situation is realized in different universes, it suggests that our lives are not solely shaped by our choices and actions but also by chance. For example, the decision to take a certain job or follow a certain career path could lead to different outcomes and ultimately result in different versions of ourselves in alternate universes. This idea challenges the notion of a singular destiny and opens up the possibility that our lives could have unfolded very differently if certain events had played out differently. Furthermore, the existence of multiverse doppelgangers raises questions about personal identity. If there are infinite versions of ourselves in other universes, are they also us in the same sense? How we perceive ourselves? Are we fundamentally connected to these alternate versions, or are they separate entities altogether? These philosophical questions delve into the nature of consciousness, and the self, and there are no easy answers. The concept of multiverse doppelgangers also has implications for the search for extraterrestrial life. If there are other universes with different physical laws, it follows that there could be universes where life exists in radically different forms or with entirely different chemical compositions. Exploring the possibilities and constraints of life in these alternate universes becomes a fascinating area of scientific inquiry. While the idea of multiverse doppelgangers is intriguing, it is important to approach it with caution. As of now, there is no direct evidence to support the existence of these alternate versions of ourselves. The multiverse theory itself is still a hypothesis without concrete empirical confirmation. Nevertheless, the concept ignites our imagination and prompts us to contemplate the vastness and diversity of our existence. In summary, the multiverse theory brings to light the possibility of multiverse doppelgangers, alternate versions of ourselves living in parallel universes. These doppelgangers could have made different choices and experienced different outcomes, challenging traditional notions of free will and personal identity. The concept also extends to the potential diversity of life in alternate universes, expanding our understanding of what could exist beyond our own world. Though lacking direct evidence, the idea of multiverse doppelgangers provokes thought and feeds our curiosity about the nature of reality and the infinite possibilities of the multiverse. The multiverse theory has sparked a multitude of debates and discussions among scientists, philosophers, and the general public. One prevalent question that arises is whether the multiverse theory is testable or merely a speculative concept. Critics argue that since the existence of other universes cannot be directly observed or measured, it falls outside the realm of scientific inquiry. They assert that the multiverse theory does not meet the criteria of falsifiability and therefore cannot be classified as a legitimate scientific theory. However, proponents of the multiverse theory argue that while direct empirical evidence may be lacking, indirect observations and theoretical models provide support for its validity. They believe with further advancements in technology and scientific understanding, we may one day discover ways to detect and explore other universes. One proposed method for testing the multiverse theory is through the study of cosmic inflation. Inflation is the rapid expansion of the universe that is thought to have occurred shortly after the Big Bang. According to the multiverse theory, inflation could create an infinite number of universes, each with its own unique properties. By studying the patterns and fluctuations in cosmic microwave background radiation, scientists hope to identify signatures that could indicate the existence of other universes. However, this approach is still in its early stages, and more research is needed to develop conclusive evidence. Another avenue for testing the multiverse theory lies in the field of particle physics. Some scientists believe that if other universes exist, they could interact with our universe through the gravitational force. By detecting gravitational waves or other gravitational effects that cannot be explained by known phenomena, researchers may be able to support the existence of parallel universes. Additionally, advancements in high-energy particle collisions, such as those conducted at the Large Hadron Collider, could potentially yield evidence for the multiverse theory. Despite the current lack of direct empirical evidence, the multiverse theory continues to inspire scientific research and exploration. It serves as both a thought-provoking concept and a driving force